All right, today we're going to talk about percent composition. Actually, there's also a second part to this section that is empirical and molecular formulas, but we are going to do that in a second video. Shouldn't take too long, but a little over 15 minutes probably. Okay, percent composition is defined simply by the percentage by mass of each element in a compound. So here's our formal fancy definition. You'd have your mass of the element divided by the total mass of the sample times 100. However, sometimes we don't have pure samples to deal with, so we can use the molar mass of the element as well as the molar mass of the compound as the total mass to do this. Okay, so what does this look like? Well, first of all, we want to find the percent composition for calcium nitrate. Okay, here's our formula for calcium nitrate because, as a reminder, calcium is a 2 plus, nitrate is a 1 minus. So when you crisscross them, you need two nitrates to balance out each calcium because the overall charge has to be equal to 0 for an ionic compound. Oops. Okay, so first step is we have to find the molar mass of the entire compound. Now, we've already done this. I'm going to do this a little bit differently and show a little bit more of my work, and you're going to see why. So for calcium, there's one of them for a total of 40.08. Okay, for the nitrogens, remember we have to distribute, so we're going to have two nitrogens, find it on the periodic table, 14.01, which is going to be 28.02. And then lastly, you've got oxygen, which is 6 times 16.00, gives you a total of 96 for the contribution of the oxygen. And this is going to be, if we add all of that up, we total it out here, the total compound is going to be 164.10 grams per mole because we're dealing with molar mass. Okay, now we're going to go ahead and find the percentage of each one based on what we just had. Now remember, we just had the fact that the total molar mass for this compound is I don't want red here, is 164. There we go. Maybe, let's try that one more time. I want black. There we go. The total molar mass for this compound is 164.10 grams per mole. And we got to find the percentage for each one. So first off, we've got the percentage of calcium, and all we have to do is take calcium's contribution, 40.08, divide it by the total, 164.10, times it by 100, and we should end up with 24.42% calcium. And we're going to do two decimal places here. We're going to trump the sig figs just a little bit, so we're going to have two decimal places. So calcium, 24.42. Okay, next one was nitrogen. Nitrogen's total contribution, so not just the 14.01, but the fact that the total, there are two of them, so 28.02 divided by 164.10 times 100 is going to give us 17.07% of nitrogen. And then last but not least, our percentage of oxygen is going to be the oxygen's total contribution, which was 96.00, divided by 164.10 times 100. So this time we get a total of 58.50 for our percentage of oxygen. Now just a quick double check, you always want to add these percentages back up. You should come out really close to 100. If you add these up, you end up with 99.99%, which is well within limits. If you get really anything much further than a couple tenths away, then you've probably done something wrong. So okay, let's do one more here. The next one we're going to do is back to our ibuprofen. We're going to find the percent composition. Now we've already done the molar mass calculation, so for the sake of time, here are all your contributions. There are 13 carbons for 156.13 for carbon. There's 18 hydrogens, 18.13 grams for hydrogen. 2 times 16, 32, which gives us a grand total of 206.31 grams per mole. All right, so if we do our next ones, all right, we're going to have for the percent of carbon, you would have had, we take that 156.13, we divide it by 206.31 times 100, excuse me, we get 75.68% carbon. Okay, then the next one that we had was hydrogen, and for hydrogen you're going to have 18.18 divided by 206.31 times 100 is equal to 8.81% of hydrogen. Again, all of these to 2 decimal places. And then last but not least, for your percent of oxygen, you should have had 32.00 divided by 206.31 times 100. That's going to give us our 15.51% of oxygen. Okay, and those are our percent compositions. Okay, pretty straightforward. I'm going to stop here and do a second video for the next part of this section on calculating empirical and molecular compounds.